of the key things to understanding how people learn math is understanding that your brain processes it in 3 different ways, and possibly more than that. But there are 3 main ones that I know about, and that is the verbal, which is the written or the spoken word, the actual word itself, the language, vocabulary. And then there's the quantitative, which is what the verbal word means, but it's like the amount. So the quantity that the word means. So like the number 1, I just said 1, and there's 1 finger that I'm holding up. That is the quantitative. And then there's the symbolic, which everybody knows as just the number thing. And then you have actually the number 1. Those are 3 different ways that your mind processes number. Once you understand the way the brain intakes math, you might be able to present it better. So most people get the first stage, which is the verbal stage. Most people get that done well. So by the time a kid is usually, 2 or 3, they can say 1, 2, 3, 4, 5 and count all the way to 10. They may not have any idea what it means, but they can say the words. And that's really all the first stage is getting that sequence down. Can they say the words in order from 1 all the way to 10, and then from 1 all the way to 20? What I would encourage you to do is, instead of just teaching kids to count to 10 or to 20, but go far beyond that. Teach them what it's like to count in the hundreds or even in the thousands, and get them to hear those word sequences also. You might also teach them to skip count, because those are the precursors to multiplication. The next stage is the quantitative stage. And the beginnings of it kind of come along with the verbal stage, in that when the child is saying 1, 2, 3, parents are also usually teaching them finger counting. That's the quantitative stage. So you're connecting the word to an amount, in this case of fingers. So oftentimes, like I said, parents will say, oh, how many fingers old are you? Or hold up 2 fingers, that kind of thing. The only suggestion I would have here is you might count other things besides fingers, How many pennies are here? How many apples are here? How many bites did you take? That sort of thing, getting them to connect the word with the quantity that word stands for. Also, start out with a certain amount, like 3, and then add another amount to it, and have them count up from there. Or say, oh, if I've got 3, now I've got 4, 5. I've got 5 altogether. Or in the reverse of that, have them start out with an amount and remove a couple of things from it and see if they can tell how many are left, or counting 5, 4, 3. The last stage that develops in a child's brain is the symbolic stage, and that's true for most everything. The symbolic stage is the most complicated, because it's not a word and it's not an amount. It's in a symbol that means the word and the amount. And so it can get a little bit more in depth. And here's where a lot of times there is a disconnect in a child's mind. I understand the word 1, I understand the symbol 1, but they might not yet get the quantity connected to both of those. There are tons of resources to help with this. Decks of cards are great, because it's got the quantity and the symbol both on it. There's also toys, little counting toys that you can get. All of those are great at helping to make this stage more fluent. Just because a child can recognize a number doesn't necessarily mean that they understand the amount. Some kids do, and some kids get it just like that, and they're great. Other kids need a little bit more time. I remember one time when I was in kindergarten, because I thought that it was very strange. I was somebody that naturally understood numbers. But there was a child in my class who, when we were counting from 20 to 30, the teacher was asking us, well, what's after 29? And this one little kid, he raised his hand, he goes, it's 2010! And he was so adamant that he was right, because 10 comes after 9. Well, that's somebody that the sequence part of those numbers hasn't developed yet. He didn't understand yet that after 29 is 30. He thought, well, we've got 21, so why not have 2010? That's a disconnect. And those sort of things, once you talk to a child and count with them and work with them, you can see those disconnects, and it's easier to do some interventions when they're young. There are a lot of ways to bridge this gap. One of them, as I have said is just talking to the child. Having a conversation, asking them questions. What comes after 9? What comes after 29? What comes before 30? What comes after 19? What comes before 20? Here's one that I find a lot of kids that I tutor have struggles with, is what comes after 99? They have a hard time going from 99, that leap to 100. They know that 100 exists, but going from 99 to 100 as a part of the sequence, it's just not there yet. So that's something we have to work in, counting from 95 all the way up to 105, and then understanding from after 109 is 110, and so on and so forth. Those are some of the gaps that you might notice when you are teaching number. And when you are teaching number, and I say teaching number and not teaching math, because teaching numbers, in my mind, is different. Math is what you do with numbers, but teaching what a number is slightly different. But those are some of the gaps that can open up, whether it is a verbal gap, whether it is a quantitative gap, or whether it's a symbolic gap. Those are some gaps that you might find that open up sometimes. And when you realize it, when you're talking with the child and you realize that there is a gap, then you can go in and you can discuss and teach and show them the examples. You do have to repeat those instructions oftentimes, especially if a kid is struggling with understanding a concept. So in my tutoring, I often have to go over 99, 100, that jump a lot. But then I also have to do the 199 to 200 jump. Generally, once I get those two, they understand then when you go 299, after that is 300. When you get to 999, we have to do it again. And those are things that I have to repeat over and over again so that a child understands and can remember what it is. Memory is mostly achieved by repetition of a topic or an understanding or a concept. There are lots of different activities you can use to bridge this gap, and I have a few right here that I suggest. And I hope that you take this list and add your own thoughts to it and branch it out, because there are tons of things out there that you can use to teach math, not just worksheets. Not that there's anything wrong with worksheets, because practice is extremely important, but there's so much more than just the worksheet. Bridging the gap between the symbolic and the quantitative is one of the things that you can do to help your child learn basic addition and subtraction. One of the things that I love to use in this is simply a basic deck of cards. Cards have both the symbol and the quantity on every card that has a number on it anyway. Face cards don't, obviously. You might have to teach that ace means 1. That generally doesn't take long. But each card has got a specific pattern of items on it, such as the 3 has got 3 items that just go straight in a row. 4 makes the 4 items in a square. And then the 5, the arrangement of 5 is a very recognizable pattern. They automatically know it's 5 without touch counting anything. That's what we would like to achieve, because those symbols you'll see, like in 6, the symbol of 3 repeats itself twice. Baby multiplication there. And when you look at 7, the lower part of that card there is the same arrangement as is the 5. You can see 5 and then 2 more at the top. All of these cards have got similar arrangements, so it makes it easier to count them, to count the items without touch counting. Even the 10, you can see there, has 2 groups of 5 stacked on top of each other. It's important that a child can look at a group of items less than 5 and see how many there are without touch counting every single one. That's a basic understanding of quantity. It's something that takes a little time, a little skill to develop, but it is incredibly important to be able to look at a grouping such as 2 and not have to say 1, 2, or 3 and have to say 1, 2, 3, but to see those items and be able to pick it out. Another way you can bridge this gap is by writing a symbol and having your child make that many dots, or vice versa. So for instance, this is the symbol 5. You know, a little box next to it, make 5 dots in the box. You might say draw 5, or count out 5, or give me 5, like have a box of marbles. Give me 5 marbles. Count out 5 marbles. Then you want to go backwards too. Give a quantity and see if they can write the symbol. So that would look something like this. Oh, here's my quantity. How many are here? 6. Can you write that number? How many do I have in my hand? How many marbles are in my hand? First of all, if it's a small amount, like 5 or less, and they should be able to look at it and say, oh, you've got 5 marbles there, without going 1, 2, 3, 4, 5. Especially if they're more along the lines of kindergarten age. If not, then have them count it out. But those are ways to connect quantity with symbol also. One of the most common issues when learning basic adding and subtraction is dealing with the symbol and connecting it to the quantity. So for instance, this says 1 plus 2. And as we just noted in several minutes of video, that we connected quantity to symbol. But in this case, we first of all have two other symbols, the plus sign and the equal sign, though we need to make sure we define and let the kids know exactly what those mean. But also the fact that we are combining the quantities, not the symbols. And you do that by creating an addition and subtraction situation and seeing if they can write the symbols that would represent that situation. For instance, I have 1 dot. You gave me 2 dots. How many dots do I have altogether? 3. To write that situation using symbols, that's where we come in using the 1 plus 2. Notice I don't have a plus sign in the quantity because the plus sign is a symbol and this is quantity. Symbols stay with symbols. Quantities simply show what happens. I started with 1 dot. I added 2 more dots for a total of 3 dots. So the symbols that represent that situation are 1 plus 2 is 3. For a subtraction situation, can be a little bit more tricky. Let me give you an example of what not to do. Don't do this. It causes so much confusion and people don't even know why. Here's the situation. I have 5 dots. You took 2 of my dots. How many dots are left? So a lot of people, when they are drawing the symbol version of this, would do something like this. 5 minus 2 equals 3. But that's not what this means. This is simply drawing dots in place of numbers. That's not what quantity means. So a proper showing of 5 minus 2 is 3 would be more along the lines of this. I have 5 dots. I took 2 away. There are 3 left. So notice there is no minus sign and there is no equal sign in my situation because this is just a model. Now I say, write the symbols that represent the situation that I just showed you. That's when you would say 5 minus 2 equals 3. No subtraction or equal sign in the model here, but it is in the symbols because the symbols need to show the action. So by crossing the 2 out, that's how I took them away. That was the action. Well, the subtraction sign shows the action. The equal sign shows the result. However, equal sign does not mean result. We'll get into that in a later video. Don't sell this stage short. Though it can seem very simple and even intuitive, it is the basic foundation of all mathematics, especially adding and subtracting, understanding quantity and symbol, especially in number sentences like we just demonstrated. Devaluing it can cause gaps in understanding that can lead to major problems down the road, such as problems with equations. So make sure that this is practiced over and over again in fun ways. A lot more practice time. There are a ton of different games out there for memorizing basic facts. There's cards, there's flashcards, there's games. I have a few games on my playlist, my Game Zone playlist, which I will link at the end of this video, that will help you memorize your basic facts. Also card games, just any card game, so like Rummy, even Go Fish, or Solitaire. Those are great games for practicing skills, and in using the cards, you connect the quantity to the number and you don't even know it. I do caution that using actual playing cards has a much stronger effect than using a computer game. I'm not sure why, but holding the cards and actually manipulating the cards and seeing the cards somehow has a different effect when you're actually using real cards rather than just digital. Playing board games that have dice, such as things like Chutes and Ladders, those kinds of things are great for solidifying these games. There was a game when I was a kid called Hi-Ho Cherry-O, and it had these cute little buckets of cherries, and you would spin the spinner and put that many cherries on the tree. It was a goofy little game, but it was great at reinforcing quantity and number. Manipulatives are simply a fancy word for things to count. So things that math teachers use. It could be pennies, it could be beans, it could be counters, it could be blocks. Anything that you can actually manipulate and hold in your hand. Cards are actually a type of manipulative also. And connecting the skills to daily life. So have your kids see you count things. Whether if you're in a classroom counting desks and counting, 2, 4, 6, 8, do it out loud so they can hear your thoughts. Then they can understand what's going on inside your head. Or if you're just at home and you're a parent trying to teach your child, let them again see you count things, see you add things. So you're at the store. I have 3 peaches in this bag. We have 5 people in our house. Are there enough peaches for everyone to have one? Those kinds of things. Show them that numbers do play a part in real life. It's not just about dots and about games and about cards. That's only part of it. There is a multiplication connection also, and I'm only barely going to go into it, but it's repeated addition. Whenever you're adding the same number over and over and over again, multiplication is the shortcut to that. And that also involves skip counting. So adding the exact same thing over and over and over again, and skip counting, you're teaching your basic foundations for learning multiplications in another video.